Okay, another series example. So same question, find the sum or explain why the series diverges. Okay, so based on the exponents, I believe this is geometric. So let's see why. I'm going to do this twice. Solution A. I'm going to simplify the summand. So 5 over 12 minus 3 and plus 2 for the minus n. Okay, so my goal here is to work, and arrive at a times r to the n. Why am I doing a times r to the n and not a times r to the n minus 1? Well, it's because I have my series starting at n equals 0. So let's write down some formulas here. If n equals 1 to infinity, ar n minus 1. Okay, we saw this one before, and this one is a over 1 minus r. So let's say if r is less than 1, then the geometric series has a simple formula. Now, if I do a sort of a change of variables here, if I take n and replace it with n plus 1, what do I get? Well, I get n is equal to 0 now. Okay, if you take this n right here, and replace with n plus 1, what you get is, n plus 1 equals 1, so n is equal to 0. Then you get a r n, and it's the same formula. So here's some things worth memorizing. Okay, back to my solution A. I'm taking this integrand, and I want to manipulate it to look like a times r to the n. So 5 over 12 up front. I'm going to form a fraction, minus 3 n plus 2 over 4 to the n. A dot in between them, dot. So I want just n to be the power. So I'll go minus 3 to the n minus 3 squared there. And just 4 to the n underneath. So in the numerator, I have 9 times 5 is 45 over 12 times minus 3 over 4 to the n. So where am I going now? So I got what I wanted, right? I got a times r to the n. So from here, I see that a is 45 over 12, and r is equal to minus 3 over 4. So sum is equal to a over 1 minus r, which is 45 over 12 over 1 plus 3 over 4, which is 45 over 12, 7 over 4. Okay, flip and multiply. That's 45 over 12. Should have reduced that earlier, right? 45 over 12 is 15 over 4 times 4 over 7, which is 15 over 7. Aha, there we go. Solution A was to, let's go green. Take the summand, simplify it until you get A times R to the N. Okay, then you have your A and you have your R. You notice that R is less than 1 in absolute value. So I can use this formula in blue down here, this one. Okay, solution B. Solution B is when you are convinced from the get-go, from the beginning, that you have a geometric series. Okay, so in that case, you can just take you can take one term of the series, divide it by the preceding one. Okay, and that's going to give you your R, because remember this series is A plus AR plus AR squared plus right? So if I take AR divided by A, I get R. So if I'm trying to find R, and I'm convinced that I have a geometric series to begin with, let's copy down AN over here so we have something to look at. AN is 5 over 12. Okay, the original form. So A1 would be 5 over 12. Negative 3 cubed. 4 to negative 1. Negative 1. All over A0. 5, 12. Negative 3 squared. And then 4 to 0, which is just 1. Okay, and this, you can see, look, this is quite negative 3 times 4 to the minus 1, which is minus 3 over 4. Okay, so that's very quick to find R. And then A is equal to first term. Why do I have 2 R's? First term. Because of, this is my geometric series in purple over here. First term is A. So the first term is, in our case, is A0, which I was working with above. So I can quickly find R, and I can quickly find A, and I can just plug them into my A over 1 minus R formula, and you have the same calculation as above. (45 over 12, 1 plus 3 over 4, which, as above is 15 over 7. Okay, I want to emphasize solution B is when you are sure that you have a geometric series. Okay, this formula we're using, which I'm underlining in green right now, this formula here works for a geometric series. It doesn't work for any old series. works for a convergent geometric series. Okay, so if I think I have a convergent, or if I think I have a, yeah, if I think I have a geometric series, then I can use solution B. Or I use the method of solution B, rather.